Om Swastiastu. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera bagi kita semua. Namo Buddhaya and Salam Harmony. I'm Putu Ananda Savitri with my student number 221510157. We will be explaining about insertion sort and quick sort from data structure and algorithm. I'll start from insertion sort. Insertion sort is a simple comparison-based sorting algorithm. It works by dividing the array into sorted and unsorted region. Initially, the sorted region contains only the first element of the array and the unsorted region contains the rest. The algorithm repeatedly takes an element from the unsorted region and inserts it into the correct position in the sorted region. Here the example, where I have data of 12, 2, minus 9, and 21. The rule that we will use here, we'll start with the second element, which is the index 1, and compare it with the first element, which is index 0. If the second element is smaller, then swap them. Here we can see this, the data is unsorted. So we want to put the 2 to the front of the 12 because 2 is smaller than 12. So we shift it and then reach the left boundary, insert 2. Next, the second rule we have is move the next element, which is the index 2, and compare it with all previous element in the sorted region. Insert the element into the correct position by shifting the larger element to the right. Repeat this process for each subsequent element until the entire array is sorted. So here I want to insert minus 9, where I can find out that minus 9 is smaller than the previous sort, which is the 12 and 2, so we shift it to the front, and then reach the left boundary, insert 9, and insert minus 9. So the last we want to put is 21. We find out that 21 is bigger than other else, and we only compare it with the last index, which is the index 2. So let it stay there. And we find out that it's already sorted. So it's minus 9 to 12 and 21.
My complete name is Ivonia Fatima Viegas with the series number 22, 15, 10, and 85. I'm going to continue with the quick sort explanations. So basically, quick sort is the divided and conquer algorithm that works by selecting a pivot elements and partitioning the elements into two subarrays according whether they less than or greater than the pivot. Then after that, the two arrays are recursively sorted. So here's how the quick sort algorithm is gonna work. Here's some data: 12, 5, 10, 8, 1, 7, 6, 3, 26, and 2. Rule number 1, we have to select a pivot element from the array. This can be done in different ways, such as picking the first, the last, or the middle elements. After that, partitioning the array into subarrays. Two subarrays. Elements less than the pivot are going to the left side, and elements that greater than the pivot are going to the right side. So here's I choose 6 as a pivot. Elements that less than the pivot are 5, 1, 3, 2, and elements that greater than the pivot are 12, 10, 8, 7, and 26. We do the same things until we get the correct order to get the final sorted array. Choose 2 in here. We're going to with the left side first. Choose 2 as a pivot. Elements that less than the pivot are 1 is 1, and element that greater than the pivot are 5 and 3. We're going to the right side here. Element the pivot that I choose is 10. Pivot is 10, and elements that less than the pivot are 8 and 7, greater than the pivot are 12 and 26. So in here's done. We're going to with the 5 and 3. 3 as a pivot. 5 is less than or greater than the pivot. It's greater than the pivot, so it's going to the right side. we're going to do 8 with the 8 and 7. 8 as the pivot, 7 is greater than pivot or less than the pivot. It's less than the pivot, so it's going to the left side. 12 and 26. 26 as the pivot, 12 is greater than the pivot or less than the pivot. It's less than the pivot, so it's going to the left side. After all done, we combine the sorted subarrays with the pivot element in the correct order to get the final sorted array. So here is the final sorted array, which is R1, 2, 3, 5, 6, 7, 8, 10, 12, and 26. There's the correct order. Overall, quicksort is generally faster than the insertion sort for large arrays or lists, but it requires additional space of recursive calls, while insertion sort is in a place sorting algorithms. I think that is all from us that we can share or we can explain about the quicksort and insertion sort, and thank you so much.